Hey you guys, here we are continuing on with number 8 on the practice final. So let's move this up so make sure you all can see that. Okay, so here we go. Number 8 is, for people who do not have this at home, a plane traveled 100 miles to Helsinki and back. The trip there was with the same direction as the wind. It only took 1 hour. The trip back took 2 hours. Find the speed of the plane in still air and the speed of the wind. Okay, so what we have here is a distance, rate, time problem. So remember the relationship that we learned was distance equals rate times time, and that's what we're going to use to construct a system of equations here. Okay, so we have information about 2 trips. One of them was going to this location and the other one was coming back. Okay, so let's start with the trip going to Helsinki. Okay. So let's first designate, we'll say that P equals the speed of the plane in still air, and W is the speed of the wind. Okay, well, if distance equals rate times time, it tells us in this problem that the trip to Helsinki was with the wind, meaning the plane and the wind are going in the same direction, they're flying in the same direction, which means that the wind is technically speeding up the plane. So we can say that, again, rate times time equals distance. We can say that the rate going to this location is the speed of the plane plus the speed of the wind, and it tells us in the problem that this particular trip only took 1 hour. It also says that the distance to there is 100 miles. Okay, so that is our first equation that we're going to use to help us solve this problem. Okay, so we're going to look at that, put a little circle around that. Okay, next we have the trip coming back, or to and from, if you want to look like that. Okay, so again, rate times time equals distance, and it says here that if the trip there was with the wind, and that means that we can assume that the trip back was going against the wind, which means that the wind is slowing the plane down. So we can say that the rate of speed coming back is P minus W. It tells us in the problem that this particular trip took 2 hours, and again, it's not like the distance changes going from going to and from. You're still going the same distance, even though the speed might change and so on. Okay, so that's the second equation. Now let's see if there's anything we can do to modify these to make it a little bit easier for us to solve. In this one, 1 times anything is the thing that we started out with, so that one stays the same. So that's P plus W equals 100. Just move that over here. This one, if we notice that we have all of this is being multiplied by 2, that's how long the trip took. If we divide both sides by 2, cross those out, P minus W equals 50, and that is the second equation that we can use to help us solve this for both the speed of the plane and the speed of the wind. Okay, so now what we have is a system of equations, which we did in the last problem, and we can add straight down. The reason we can add right now without doing anything to anything, really, is that if we look at the W's, they end up canceling out, which is awesome for us. Okay, so 1P plus 1P is 2P. 100 plus 50 is 150. And then divide by 2, divide by 2. So the speed of the plane is 75 miles per hour. Okay. Now, once we have the speed of the plane, we know that from the relationships that we came up with up here, we can take that speed of the plane, plug it back into either of these equations to solve for the speed of the wind. Okay, so let's put it into this one. I'm not a big fan of negatives. Positives are better. So we're going to plug it in here. And when we do that and solve this for W, or the speed of the wind, we end up getting that the speed of the wind is 25 miles per hour, which in this one is D. We are off of our B, or C, or whatever it was, kick that we had before. All right, so you are also obviously welcome to pause as you need to as we go through these. I'm just going to kind of keep running through them. I think it would be beneficial to all of us. If you need to go back and rewind because you like a little bit more explanation, you are certainly welcome to do that. Okay, the next problem we have, which of the following is equivalent to 2x to the negative 4th, y to the negative 2nd, over 2x cubed to the 4th, times yx to the negative 3rd squared. Basically what we want is a simplified version of this madness, okay? I know how much you all love these problems. So you probably all should know that I have not actually done any of these problems ahead of time. So you're seeing me complete these as if I am in your shoes. So you've never seen them, and I have actually never seen them either. So we are in this together. Okay, so here we go. First thing we're going to do is distribute, get rid of these parentheses. Remember, think PEMDAS. So it doesn't change just because we have so many exponents in here. We want to get rid of those first. So we're going to leave the numerator exactly the same. We'll deal with it later. I personally think taking these problems step by step by step makes it a lot easier. Some people just want to get in and like tackle all of it at the same time. If you can do that and still keep track of what you're doing, go right ahead. I can't. I need to do step by step. Okay, so 2 to the 4th, x to the 12th, and then we have y squared, x to the negative 6th. Okay, lots of different approaches now that we're at this step. One of the things that I am seeing is that we've got this on the bottom that we can combine. Again, I like taking one piece at a time. If you want to just go right ahead and do all of it all at once, that is your prerogative, and go right ahead. Okay, so we add these exponents together. We're going to leave that 2 to the 4th. We get x to the 6th, y to the 2nd. So that's where we are. Now, if we're going across the fraction line here, again, many different ways of doing this. There's an invisible 1 on this or for that exponent. So remember, the rule is we subtract at this point. So we get 1 minus 4, that's 2 to the negative 3rd power. Let's put our fraction line in here. Negative 4 minus 6, that's negative 10. Negative 2 minus 2, that would be negative 4, and it's all over 1. And it specifies in the problem, it's not totally simplified until we have no negative exponents. So remember, the way we do that, we get rid of them, is to move them to the opposite side of the fraction line. So all of them in this case move. Yay for us. So we get 2 to the positive 3rd, x to the positive 10th, y to the positive 4th. 2 to the 3rd is 8. So 1 over 8, x to the 10th, y to the 4th, which is B. All right. And again, make sure you're writing down any questions you have as you go so that you can ask them in class. Feel free to pause. Again, you are in complete control here of that, which is awesome. Okay, here we go. The sum of 6 consecutive integers is 105. We want to find all integers. Okay, so we have 6 of them. So the first integer we will say is x. Since we don't know them, probably a good idea to identify them with something that we don't know, which we'll call x. We went through that whole, I know you all thought it was so fun to put in shapes and question marks and all that. If that's your deal, go right ahead. Okay, so if the first integer is x, and we're talking about consecutive integers, remember consecutive just means right next to each other. So 1, 2, 3, 4, etc. Those are all consecutive integers. To get from one integer to the next, we have to add 1. Well, if we're starting at x, to get to the next consecutive integer, we have to add 1 to x. So we would get x plus 1, right? Okay, then the next one would be x plus 2. Then the fourth one would be x plus 3. Make sure you all can still see that. The fifth would be x plus 4. Sixth would be x plus 5. Okay, now it's telling us in this problem that the sum of all of these integers is 105. Sum, again, that means add. So we're going to take all these integers and we're going to add them together. Notice how they are all lined up very nicely and neatly, so we can just add straight down. So we get 1, 2, 3, 4, 5, 6x. 5 plus 4 is 9, 10, 11, 12, 13, 14, 15 equals 105. Where did 105 came from? It told us in the problem that the sum of all of them was 105. All right, now we're going to subtract 15 from both sides. So we get 6x equals 90. Then we divide by 6. So we get x equals 15. Okay. Making sure in my head that's right. 6 goes into 9 once. There are 3 left over. 35. Yes, good. Okay, so x equals 15. Remember, x represented the first integer. So if the first integer is 15, well, to get to the next one you take it and add 1 to it. So that's 16, 17, 18, 19, 20. So those are our 6 integers, which happens to be C again, our favorite letter. Okay, moving on. Keep track of time here. My YouTube channel is now been enabled for uploads longer than 15 minutes, so I can not have to break this up quite as much. Okay, negative 3r plus 2s minus 2t equals 13. Negative 3r plus 4s minus 3t equals 20. 2r minus 3s plus 3t equals negative 17. Okay, now, these problems, remember we talked about 2 very important things. The first one is make sure you copied it down correctly, because if you have 1 plus or 1 minus that is off, it's going to be a very unpleasant experience for you. So, let me just double check to make sure that I copied it down correctly. Negative 3r plus 2s minus 2t is 13. Negative 3r plus 4 is 3t. Okay, so here we go. It's copied down correctly. The second thing that we talked about that is super important with these problems is staying organized. There's a lot of information here, a lot of things going on. So if we can help ourselves out in some way, we want to do that. So first thing in getting organized is label these equations, 1, 2, and 3. And then for a starting point, what I immediately look for in these problems is something to cancel out. I like canceling things out, and I think you all do too. So if I'm looking at this, I notice that if I were to combine equations 2 and 3 together, I would get the 3t and the negative 3t to cancel out. So that's what I'm going to do first, is equations 2 and 3, literally just adding them together. So when I do that, whoops, starting to get dark in here. When I do that, I'm actually just going to do it like this. Actually, let's write them down. Remember, I just said organization is key, so let's stay organized. I know that I am killing some of you with this and the redundancy. Fast forward. Okay, so when we add, those cancel out. Negative 3r plus 2r, that's negative r. 4s minus 3s, that is s. 20 minus 17 is 3, so there we go. That is one of our equations. Okay, now this is the most important thing in this next step. If we started out by canceling t's, that means we want to continue by canceling t's, okay? So, what does that mean exactly? That means that the next set of equations that I choose to combine better be equations where I see the ability to cancel or multiply to cancel really easily. So I'm looking at the fact that I have a negative 1 here, a negative 2, and a positive 3. And I'm going to choose these to combine next. So those are equations 1 and 3. But if I notice the way that they're written right now, if I try to add those together, negative 2 plus 3 is 1. They're not going to cancel. So I need to multiply actually both equations by something so that they will cancel. Otherwise, we're not going to get anywhere. So I notice that I can multiply a 2 by 3 to get 6 and a 3 by 2 to get 6. So that's what I'm going to do. I'm going to multiply the entire first equation by 3 and the entire third equation by 2. Okay? I'm going to do that in my head so that I transfer it down with the multiplied versions, of the beefed up versions. Okay, so what did I say? Equation 1, I'm multiplying everything in that equation by 3. So negative 3r times 3 is negative 9r. 2s times 3 is 6s. Negative 2t times 6 is negative 6t. And 13 times 3 is 39. Then we said the third equation we are multiplying everything in it by 2. So we're going to take each of these terms and multiply them by 2. 2r times 2 is 4r. Negative 3s times 2 is negative 6s. 3t times 2 is 6t. And negative 17 times 2 is negative 34. Okay. And now, this is awesome, because if you notice, we had a goal of getting the t's to cancel out, but check this out. The t's cancel out like we wanted to, but what happens? The s's also cancel out. That actually makes our lives a lot easier. We don't have quite as many steps that we have to go through. So now let's continue on here. Negative 9r plus 4r, that's negative 5r. 39 minus 34 is 5. Negative 5r equals 5, so we divide and we get r equals negative 1. Oh, this came out very good because now we can take that -1, plug it back in here, get s, then take s and r and plug it back into one of the original equations. Okay, so we get -1 plus s equals 3. Double negatives make a positive, so this is 1 plus s equals 3, -1, so s equals 2. Okay, now we have r and we have s, we are only missing t. Well, guess what? We have a bunch of options up here that we can take our r and our s and plug them into so that we can find our t. So I'm looking for the one that has the least amount of negatives in it. And that looks like equation 3 to me, but any of them will work. So I'm going to take equation 3, 2r minus 3s plus 3t equals -17. And I'm going to take the r that I just found and plug it in for r, the s that I just found and plug it in for s, and this will allow us to solve for t. All right, so here we go. So 2 times -1 is -2, minus 6 plus 3t equals -17. -2 minus 6 is -8, plus 3t equals -17. If we add 8 to both sides, we get 3t equals -9, and divide by 3. T equals -3. So remember, every now and then, so let's see, R, S, T, we put in order here, we get -1 to -3, 1 to -3, that would be B. Okay, now, one thing I want to reiterate on these problems, they all, as you can see, they are already complex enough. If you end up getting a fraction somewhere, something definitely went wrong somewhere. These are the types of problems where you rarely will get fractions, okay? So if you start out and you're already getting fractions in the beginning, double check your work. Something went wrong. All right, we're going to switch videos and move on to number 12.